Hi guys, welcome to another video of Physics 2. Just remember that this is a video that is in a playlist, so if you don't know about the playlist, well, I'm gonna post that playlist over here. Okay, so this is the problem number 2 about dynamics. So in this case, we have an inclined plane. Okay, so there is a block over here, and of course that block is going to travel down through the inclined plane due to the fact of the um, gravity force that is going to be the weight. Okay, so I'm going to draw over here that this is going to be the direction of the motion. So if you can see in this drawing, there is no force, there is no external force applied by a person or something like that. There is only the force of the weight, and we need to find the acceleration in which this block is going to travel and the normal force. Okay, so I'm just gonna write here that this is an inclined plane. Okay, and remember that in this problem we are not consider friction. In the future problems we're gonna do it, but not right now. Okay, so the first thing that we are going to do is the free body diagram. Remember that in the previous video I told you that I'm just gonna be call it like this: free body diagram, FBD. Now, one important thing about the free body diagram is that, well, if you remember, the free body diagram is a Cartesian plane. And in the previous example, the surface was horizontal, so the angle was 0 degrees. So one important thing about the free body diagram is that the x-axis of the Cartesian plane must be parallel to the surface. So in that case, my free body diagram will be something of, like this. The x-axis, I repeat, must be parallel to the surface. So this is x and this is y. Okay, so remember that in the middle I'm gonna have this dot over here that is going to be the block. The particle is going to simulate the block. Okay, so remember that there is always a force. There is always a force that, if it's not mentioned, it's always there, and that force is the weight. Okay, and that weight points to the center of the earth all the time. Okay, so that is the weight. But if you see, the weight is not in the x or the y axis. So the idea of having a Cartesian plane is that we can have our forces on the axis, because if they are on the axis, I can treat them as x and y, just as the rectangular components of a vector. So this weight over here is going to be decomposed on the rectangular components. Okay, so this is going to happen only on those cases where I have inclined plane. Okay, so I'm gonna have, remember that the rectangular components are gonna be on or over the axis of the Cartesian plane. So I'm gonna have a component over here, and I'm gonna have a component over here. Because the components are over the axis. And if you see, this little angle of 35 degrees is going to be this angle over here, 35 degrees. Now, I'm not going to get into the demonstration of how is this angle that I have here is equal to this angle over here. If you want to know why, well, I'm going to give you a card about this problem over here, about this explanation. I'm gonna leave it over here if in case you want to know why this little angle over here equals this angle over here, okay? Because we are going to need it. Well, we don't need to know why, because but if you want, I'm gonna give you this one, okay? I don't want to kill your curiosity, okay? So this is going to be wy, and this is going to be wx. So if this is wy and this is the angle, so the formulas for weight are going to change. So wx is going to be the weight times the sine of the angle, and wy equals the weight times the cosine of the angle. Because if you see this angle over here, this is the hypotenuse, so this is the adjacent, and the adjacent, the trigonometric functions that we use for adjacent is cosine. So cosine now goes to wy. Now I repeat, this only applies to inclined plane, and there is a demonstration about why this angle is this one, and it's over here in this video. They can explain you that, okay? But every time that we have an inclined plane, I'm going to use these equations. I just don't want you to get confused. These equations only apply an inclined plane, okay? So I got the weight, I got wx, wy, and remember that every time that we got a surface and the block is over that surface, we're gonna have normal force, and the normal force is going to be perpendicular to the surface and opposite to the weight. So the normal force is going to be this one over here. That is normal force. Okay, so this is my free body diagram. I got all the forces involved. There is only the weight and the normal force. So now let's begin with the analysis. Remember the reference system: right positive, left negative, up positive, and down negative. Okay, so let's begin with the x-axis. X-axis. So if you see, well, when I talk about x-axis, I refer to the x-axis of the free body diagram. So this axis over here. So the motion is on the x-axis. So remember, the sum of all forces in x equals, in this case, there is going to be motion, so it's going to be mass times acceleration. Okay, so let's see the forces that I got in x. I only have wx and goes to the right, so it's going to be positive. So wx equals mass times acceleration, and I need to find acceleration. So acceleration equals wx over mass. Okay, and wx is, according to the equation that I just wrote, is weight times the sine of the angle over the mass. So acceleration equals mass times gravity times the sine of the angle over the mass. So if you see, I can cancel the mass over here with the mass over here, and at the end I can find the acceleration of the object, that is going to be the gravity times the sine of the angle. Now this is very interesting because it doesn't matter the weight of the body, I mean the mass of the body. The only thing that affects the acceleration in which is going down will be the gravity and the angle. So that's very interesting, guys. So let's do it in our calculator. So remember that the gravity is going to be positive in this type of problems. So it's going to be 9.8 times the sine of 35, okay? And that is the acceleration, okay? So I'm gonna save the value in A. Now, to be honest, it's a very big acceleration, very big, okay? But okay, I guess I said in the previous problems that I was going to perform more realistic problems, but I'm sorry. 5.62 10 meters per second square, which is a lot. Okay, I'm sorry. So this is letter A. And I just save it in my memory A because at the end I'm going to do something with that acceleration. And the normal force. Well, let's go to the Y analysis. Y-axis. Y-axis. So the sum of all forces in Y equals, well, if you see, the object is not going to move on the Y-axis. So in this case, it's going to be 0. Okay, so what forces do I have on the Y-axis? I got 2. The normal force that goes up, so in this case it's going to be positive, and the Wy that goes down, and it's going to be negative. So normal force minus Wy equals 0. So normal force equals Wy, that is weight times the cosine of the angle, because remember the equation that I just wrote over here. So normal force equals the mass times the gravity times the cosine of the angle. Okay, so let's find it. Mass, how much is the mass? 7 kilograms, parentheses, 7 times 9.8, parentheses, times the cosine of 35 equals. Okay, so that is the normal force. Remember that the normal force is a reaction force. So normal force equals 56.1938 newtons. Okay, I'm gonna circle this, and this is letter B. Okay, now imagine that I have a distance over here. From this point to this point, I got a distance of 0.7 meters. Okay, how much time is going to get to this block to travel that distance and get to the floor? Okay, so the only equation that I need to use is this one. Final position equals initial position plus initial velocity that multiplies the time plus acceleration times square over 2. Now imagine that I just drop the object. If I drop the object, that means that I'm not pushing it. So if I drop the object, the initial velocity will be 0. And remember that most of the time the initial position is 0. So I can cancel this one and this one. So the final equation that I'm going to use is this one. Final position equals acceleration that multiplies the time square over 2. So from that equation, I'm going to isolate time. So time equals 2 times the final position over the acceleration, and this will be inside of a square root. So let's do it. Let's do it in the calculator. Okay, so square root fraction 2 times the final position, and the final position will be 0.7 meters, 70 centimeters. 2 times 0.7 over the value of the acceleration, which is this value over here, and I already saved it in my memory A of my calculator. So how much is that? Okay, 0.49, less than the half of a second. So time equals 0.4990 seconds. And I'm going to circle this answer over here. I'm not going to write it that is going to be the letter C, because of this is something that I just came up with. So this is the problem number 2 about dynamics, inclined plane without friction, and there are no other forces involved. Okay, and well, I hope you understood this topic, and later on we're gonna have more videos about it. So take care, guys. Bye bye.